If we want to discuss inverse functions, we also need to be able to find inverse functions. An inverse function undoes what the original function did to a number. For example, if I have f of x is equal to 2x plus 5, I need to figure out what's going to undo that. Well, the way to figure it out informally is I'm going to start with the number x, and the first thing that I do to that number is, if I were to put a number in here, is I would multiply it by 2. And then 2 times x gives me 2x. And then the next thing I do in order of operations is I'm going to add 5, and that gives me 2x plus 5. So I now need to figure out how to undo this series of operations. And informally, what I'm going to do is I'm going to start with the number x, and I am going to undo adding 5. Well, the opposite of adding 5 is subtracting 5, and that will give me x minus 5. Then I need to undo multiplying by 2. Undoing multiplying by 2 is either multiplying by 1/2 or dividing by 2, and that's going to give me x minus 5 over 2. So if 2x plus 5 is my function, informally, x minus 5 over 2 would be my inverse function. The way that you verify that this is in fact the inverse of that function is you compose this function with this function in both directions. So I'm going to call this f inverse of x, and now I'm going to compose f with f inverse of x. So from our composition of functions lecture, we say we write down the outside function, except where there's an x, we put parentheses, and inside the parentheses, we write down the inside function. So I'm going to write down the outside function, which is 2x plus 5, except where there's an x, I'm going to put parentheses. Inside the parentheses, I'm going to write the inside function, which is f inverse of x, which is x minus 5 over 2. Now I'm going to simplify this. Well, 2 divided by 2 is 1. And then 1 times x minus 5 is just x minus 5 plus 5. 5 minus 5 is 0. So that gives me x. I also have to perform the check in the opposite direction. F inverse of f of x, and hopefully get an x out of it. In this case, the f inverse function is my outside function. So I'm going to write that function, except where there's an x, put parentheses. So I have x minus 5 over 2. And inside the parentheses, I'm going to write my inside function, which is 2x plus 5. And then I'm going to simplify. 2x plus 5 minus 5 is 2x over 2. And 2x over 2 is x. So I have verified that 2x plus 5 and x minus 5 over 2 are inverse functions. Do a couple more examples of informally finding inverse functions. The next function I want to find the inverse of is the square root of 3x plus 2. Like the last time, I'm just going to make a little arrow diagram. I start with the number x, and the first thing I do in the order of operations is I multiply it times 3. That gives me 3x. Then I want to add 2 to that number. That gives me 3x plus 2. And then finally, I want to take the square root of that number. And taking the square root of that number is going to give me the square root of 3x plus 2. So that is my mapping of my original function. So now I want to go backwards. So I start with x, and we undo taking a square root by squaring the number. So I'm going to just write x squared, and that gives me x squared. I undo adding 2 by subtracting 2. That's going to give me x squared minus 2. And I undo multiplying by 3 by dividing by 3. And that gives me x squared minus 2 all over 3. Now I'm going to call that f inverse of x. And I am going to actually check to verify that these functions are inverses of each other. So first step is to find f of f inverse of x. Write down the outside function, which is f of x, except where there's an x, put parentheses. So I'm going to write the square root of 3 parentheses plus 2. Inside the parentheses, I'm going to write the inside function, which is x squared minus 2 over 3. And now I want to simplify. And the result of my simplification should be that I get just the letter x. So first step, 3 divided by 3 is 1. And 1 times x squared minus 2 is x squared minus 2 plus 2. X squared minus 2 plus 2 is just x squared. And the square root of x squared is x. So the first composition works. The second composition I want to do is I want to find f inverse of f of x. So I'm going to write down my outside function, which is x squared minus 2 over 3, except where there's an x, I'm going to put parentheses. X squared minus 2 over 3. Inside the parentheses, I'm going to write the inside function, the square root of 3x plus 2. And now I'm going to simplify. First thing I'm going to do is I'm going to square the square root of 3x plus 2. And that is going to give me 3x plus 2 minus 2 all over 3. 3x plus 2 minus 2 is 3x over 3 equals x. So I have verified that those two are indeed inverse functions. Finally, I'm going to look at a function that we have seen before, and that is 1 over x. So if I start out with x, what do I do to it to get 1 over x? Well, I raise it to the negative first power. Or you can say, take the reciprocal of it. Well, if I want to undo that, I start with x going this way. Well, how do you undo taking the reciprocal? Well, you are going to take the reciprocal. And I get 1 over x. I'm going to call that f inverse of x. Well, notice that, hey, 1 over x and 1 over x, I got the same thing. So let's see if those actually are inverses of each other by composing them. So f of f inverse of x says to take the outside function, which is 1 over x, except where there's parentheses, write the inside function. So that gives me 1 over x. Well, dividing by a fraction is the same thing as multiplying by its reciprocal. So that is 1 times x over 1. which is just x. And you should see, because I'm going to be using the exact same functions, f inverse of f of x, I'm going to get the exact same work. I'm going to write 1 over x. Dividing by a fraction is the same thing as multiplying by the reciprocal of the denominator. 1 times x over 1, which is just x. So the reciprocal function is the inverse of itself.